All right, there are some things that you need to know. Combining typically means adding or subtracting functions. And there's two ways that you can write these and mean the same thing. F of x plus g of x, or f plus g of x. F of x minus g of x, or f minus g of x. The other thing that you're going to do is multiply f times g of x, or f of x times g of x. And then add, subtract, multiply, and divide. So the way that they write it, you just need to know it means you are adding them together. Now, to actually do these, we are going to need to know what f of x is, and we're going to need to know what g of x is equal to. F of x is 3x minus 1. G of x is x squared minus x minus 2. Typically, the adding is not going to be an issue because you just combine your like terms. F of x plus g of x, you're taking your 3x minus 1 and you're adding x squared minus x minus 2. And I would suggest putting it in order of exponents. Is that better? 3x minus x is 2 x's, and negative 1 minus 2 is a negative 3.
So, I think I found my problem. I'm too busy writing down the problem, I don't hear anything you say. Does anybody else have that problem? Just making sure.
The good news is you can go back and watch the video again and stop and pause if I'm going too fast, or you take your notes and watch the video again and you've already got it written down, so then you could actually follow along and listen, right? In the event that you have time. What does the negative in front of a function do? What did you say? Yeah, you have to distribute the negative. So it changes all of those signs. Negative x squared, 3x plus x is 4x, and negative 1 plus 2 is a positive 1. If students miss this problem, it's typically because they did not distribute the negative to everything. How do you multiply a binomial times a trinomial? And this is the reason I don't like saying FOIL. And when I taught Algebra 1, I did not call it foiling it, because foiling only works for a binomial times a binomial, and we have these problems. So how do you multiply those together? What is the idea behind FOIL? You're distributing, you're multiplying your first term by everything. So we're just going to multiply this 3x, we're going to distribute it. 3x to the third minus 3x squared minus 6x. And now we're going to distribute the negative 1. Negative 1x squared plus x plus 2. Notice when I did the second distributing, I didn't keep it on a horizontal line. I moved it underneath and lined up like terms, so that now all I have to do is combine them. 3x to the third minus 4x squared minus 5x plus 2. And for the division problem, we have the 3x minus the 1, x squared minus x minus 2. If we can divide, then what we're going to need to do is factor this denominator. Are there factors of 2 that subtract to give you a 1? Yes. X times x and 2 and 1. 2 is bigger than 1, so it's going to be the negative 3x minus 1 on top. Nothing divides out, so there's your final answer. Now, what is domain? Your input values, the x's. Is there any restriction on a line? What's the domain for 3x minus 1? It's a straight line that goes forever, right? So negative infinity to infinity, all real numbers. What about parabolas? This is quadratic, x squared. Is there any restriction on graphing parabolas? Okay, but that's the range. That's the y value. Are there any restrictions for the input value? No. And that's why when I had you graph them, I said you had to put those arrows to show that they go infinitely forever, right? So this domain is all real numbers. This domain is all real numbers. We added together and we got a parabola. What is the domain of parabolas? All real numbers. We subtracted, we got a parabola that was turned upside down. What is the domain? All real numbers. We multiplied and we had a cubic function. What does the cubic function look like? That's one of our basic curves. The little snaky thing. Okay, so is there any restriction on cubic functions? So the domain is all real numbers. Now, this is where the restriction comes in. We are now dividing. We had all real numbers, but now we're dividing. What number can you never divide by?
0.
This is why we needed it factored. What makes x plus 1 0? If x is negative 1. What makes x minus 2 equal to 0? If x is 2. So this is going to have a restricted domain. X such that x cannot equal a negative 1 or 2. And we call this set builder notation. Everything else will work. Sometimes it's easier to say what it cannot be versus everything that it can. Now, if you were going to write that in interval notation, the negative 1 comes first. So you would say negative infinity to negative 1 with parentheses because it cannot equal. And then union negative 1 to 2. And then union 2 to infinity. And all of those are going to have parentheses. I don't care which way you write it. Okay? I don't care. You can say what it's not for the domain, or you can say in interval notation. And tell me what it is.
Do the whole numbers have parentheses?
Because it cannot equal a negative 1 or a 2. If it does, then you're forcing it to be dividing by 0. And you cannot divide by 0 ever.
So if we do any of these on our work today, they will all be parentheses.
Correct.
And it won't be with division.
Do what?
Will it only be with division like the multiplying?
It depends on the function. If you have a function where you're dividing to begin with, let's see. Yeah, let me do this one. This is example 7. And it's the same thing. We're going to add, subtract, multiply, and divide. On problem 7, f of x is a square root of x minus 1. And g of x is the square root of x. Okay, so from the beginning, where does the starting point begin? what does the -1 inside the function do? You go right 1. So when you move right 1, remember the square root function starts at 1, 0, or 0, 1 and goes this way. So we're going to start, if I was graphing it, I would go to that 1, 0, and it would go this direction. So what is the domain? 1 to infinity. Now, can it equal 1? What is the square root of 0? So yes, this one can equal. Now, here's this one, the square root of x. What is the domain for this one? Where is your starting point? 0, 0. So 0 to infinity. It's starting here and moving on. Now, when you start adding these together, f plus g of x, we have the square root of x minus 1 plus the square root of x. When you're adding square roots, you can only add them if the stuff underneath the radical are identical. So you cannot simplify this any further. Now, which domain is more restrictive? 1 to infinity or 0 to infinity? 1 to infinity is the domain. We're going to subtract. You cannot subtract radicals unless the numbers underneath are identical. So that one will not simplify. What is the domain? Which one is more restrictive? 1 to infinity. Right here. This one on a number line, when you're graphing it, you're not counting the 0 to infinity because this one does not have 0 in its domain. So we're throwing out the parts that aren't in all of them. When you are multiplying, how do you multiply square roots? Square root 2 times square root 3 is what? Okay, so you multiply the numbers underneath the radical. How do you multiply x times x minus 1? Distribute the x. Now, I told you if you're not sure what the graph looks like, you may want to graph it. This is the square root of x squared minus x. So while we have this part of the graph, it was not in the original domain, so we're not even going to worry about it. This graph starts at 1, 0. So the domain here is 1 to infinity. Okay? F divided by g of x. So we have the square root of x minus 1 divided by the square root of x. If you can divide, then you would divide. You cannot divide x minus 1 by an x. So you would just write them all underneath 1 together. Now, we are dividing. We cannot divide by 0. 0 is not in our restricted domain. So we're going from 1 to infinity.